Yeah, once again, you are welcome to back BSc Science Education Consultants, where understanding is breakfast and continuity of learning is guaranteed amidst what other people term as lockdown, but which we don't find in our vocabulary because we believe that term comes in the vocabulary of those ones who are not hardworking. Please continue following us, continue studying with us, continue sharing our video lessons with others so that they can also achieve, we all achieve, and we build our nation. As we continue with the principle of superposition of electric forces, that is Senior 5 Physics Paper 2, Electrostatics, we just add on. We have had some calculations and we see how we can treat them. So today I'm bringing another case that is a bit different from those ones that we have looked at so that we can expound on our knowledge. And there we go. Tr Cos, we are saying charges of -8 microcoulombs plus 6 microcoulombs and plus 10 microcoulombs are respectively placed in air at points A, B, and C are shown. As you can see, this is point A. The charge is there. The distance from here to here is 4 centimeters. This is point B, the charge is this, and this is point C, the charge is this, and the distance here is 3 centimeters. Now, the question: calculate the force on the charge at B and on the charge at C. So you can see that we want to know the net force on that charge, the net force on the charge at B. How do we do? We said by principle of superposition that the charge on B will be, the force on charge at B will be due to the force on charge at A and also be the force from charge at C. And then we deal with their vector sum. The vector sum which has to bring in the issue of the direction. The direction this time not on the same straight line, but we shall see how we handle, and you are going to appreciate. I wish you a very good lesson. Here you go. So this charge at B experiences a force due to charge at A. So which force? This charge is positive. This charge is negative. So this charge at B, being our focus, will be attracted by this one. In short, it will be taking that direction. So there will be that force. Okay? Then I can maybe represent it like this. This is our B, and then this is our A. The charge here is -8 microcoulombs, and the charge here is +6 microcoulombs. So this charge is being attracted. In other words, if I try to take this charge towards A, would it go there? Yes, because they are of opposite charges. And remember the law of electrostatics that we began with, that charges which are opposite attract each other. So this one will be attracted. So that force would be in that direction. That is force on B due to A. There is another charge here, which is a positive of 10 microcoulombs. Would this one be going downwards or upwards? If I try to bring this charge, which is positive, towards this positive one, it will be repelled. In other words, this one experiences a force from this one that tells this go away, and therefore we would have that force in that direction. So that is force on charge at B due to charge at C. So we can continue and we see how we treat that one mathematically. Mathematically, we say that force is 9 exponent 9, then into the different charges, then divided by the square of their separation. Meaning, if I can deal with the first one, so the force on charge at B due to this one at A so the magnitude here, so we begin, this is 9 exponent 9, then one of the charges is 6 exponent negative 6, remember micro, exponent negative 6, then this one is 8 exponent negative 6, then the separation between them is 4 centimeters, which you must change to meter, and that is 0.04, and that one must be squared. And what is this? When you press on the calculator, you'll get a force of 270, newtons. It is towards up here. So I can just indicate it like that one, so that as I come to treat it, then I don't experience any challenge. Look, the force on B due to the one at C. How do we handle? This one was force on B due to one at A, and the direction was not this, but it was this. So we are on this one, the force on B due to C. The force on B due to C, we can write it here. Force on B due to C is in the upward direction, and we substitute in our formula 9 exponent 9 into one charge is 6 exponent negative 6, then this one is 10 also exponent negative 6. Then the distance of separation from here to here is 3 centimeters. When changed to meters becomes 0.03, but remember that one has to be squared, and when you press that one on the calculator, you'll get 600 Newton. So you can see we have got now the two forces, but in which direction? This is one is in the upward direction, and this one is in the horizontal direction. So if we can combine them, we have this, we have this. So they have to be coming from the same point. So if you can combine them, this one, then also that one. So the up one is this one. This is 600 Newton, and the horizontal one in this direction is this one, which is 270 Newton. How do we get the resultant? The resultant is got by, you can just draw, connect these ones simply, make sure they are horizontal, and then now from this point, so this will be the resultant, and you can see that this is 600, so you can have your 600 here and 270. When you go back to mathematics, actually primary 4 or 5 around there, the student will tell you that if I have here, and I have here, and I want here, I use Pythagoras Theory. We are using the same, that will give us that the resultant force will be the square root of 270 squared plus 600 squared under the root. And when done very well on our calculator, we get 657.9514. Remember, this is the force, and the SI unit of the force is Newton. One other most important thing is that you have to remember that force is a vector quantity. Therefore, it must always be given in terms of its magnitude and its direction. So, how do we give the direction here? You see, it is at this, it is along the resultant. So, how do we handle? We just calculate this angle. Maybe you call it alpha. So, if that is our angle alpha, then how do you handle? We just say tan alpha opposite, which is 600 over adjacent 270, And when you take an inverse and continue, you'll finally get your alpha as 65.8. 65.8 degrees. It is very important, and we can conclude that the resultant force is a force of 657.9514 Newton at an angle 65.8 above. This is the negative axis when you draw like this. So you see it is here. Okay? It is there. So it is above the negative horizontal axis. I would wish that you avoid using the word above the positive or the negative x-axis, because this may be any horizontal axis, not necessarily x-axis. So don't be so specific. Let it be like that. At an angle of 65.8 above, it's above the negative horizontal axis. This is what we want, so that you continue doing all these things without any challenge, without any disturbance. Without forgetting, by the way, to subscribe at our channel, Back Science Education Consultants, BAC. Encourage others, but our issue is here. We are looking at yet another. We have point charges of -5 microcoulombs, +4 and -3, as you can see them, and we are told this one is inverted, and then we are required to calculate the resultant force at C. In other words, the force on the charge at C, the force on the charge of -3 microcoulombs. How do you go about that? We just add, we get the vector sum of the forces due to charges at A and charges at B. As we do that, we get the force at what? The force at C. That's how good science is. That's how best physics is among all the sciences. Let's go. We can do some sketch so that it can simplify our work. This is a C, this is an A, this is a B, and then we try to see if I bring this towards this one, I bring this -3 towards this -5, how does it get a force? Of course, it will be repelled. In other words, this -5 will be pushing this charge. It would have a force that is moving in that direction. So it is telling this charge, go away, I don't want you, because we repel each other. Okay? So the force on this, it is making it move upwards. So therefore, if I can use some dots, I will show you that this is a force on C due to a charge at A. Okay? And of course we shall calculate it. Let's look. If I try to bring this charge towards this side, what happens? Yes, just like the Bible says that on the judgment, they will say, oh, for you fed me, come this side. Then those ones, I don't know them. So this one will be like, oh, come. So you'll be calling it, come. This one is calling this one. So there is a force towards this direction. So there is a force. So this is force on C due to B. So you can see that we have two forces, one in this direction and one in this direction. This means we shall also need to get some angles there so that you can see how we treat it. So before I leave here, let me also handle the angle thing, then we can move on. This is 20 centimeters, this is 10, this is 20. So if I would divide this one so that I get the right angle triangle here, I'll divide this one by 2, So this will be 5, this will be 5. And if I call this angle, let me call it angle theta. So if I call it angle theta, I use cos. Cos theta is this over this. So will be the cos inverse of 5 out of 20. And when you press the cos inverse of that on your calculator, you shall be able to get theta as 75.5 degrees. Yes, we have been able to get the value of theta as 75.5 degrees. Then we can also see how we treat here. So if this angle is theta, you can see that if you have these two lines, you have your lines like this angle will be equal to this. So that shows that this angle, of course, will be equal to this, okay? And you can see this one is opposite to this, so they are equal also. So this one is also theta, okay? Is also theta, and so we, in the same way, since this angle is theta, actually this one is also theta because they are equal. This side is equal to that. So since this is theta, then this one will also be, that one will also be theta. So we are getting these two angles as theta, but we have already calculated our theta. So this angle is 75.5 degrees, and this one is also 75.5 degrees. So we need now to calculate this force and that force, and then we finish. So we can move on, and we say the force on C due to A is 9 exponent 9. Force on C due to A, this one at A was 5, then this one is 3 exponent -6, then 5 exponent -6. Then the distance of separation between this and this is 20 centimeters. In meters it becomes 0.2. Remember, it has to be square. Okay? When you press it on the calculator, that force, you are supposed to get 3.375 Newton. 3.375 Newton. Okay? Can we get this force on C due to B? So force on C due to B is equivalent to, of course, we use our formula. Then this one is 3 exponent -6. Then this one at B is 4 exponent -6. Then the distance of separation between C and B is 20 centimeters, which becomes 0.2. And when you press it on calculator, you get 2.7 newtons. We are able to get 2.7 Newton. So we can now show the directions. Of course, we saw this one was at a certain, so we can represent this one here. We have this one force, which is 3.375, and it's at an angle 75.5 degrees. Then we also have this other one, the one that is going down, which is 2.7 Newton, and below this angle is also 75.5 degrees. Our task is reduced. We just have to resolve this, which I want you to do. I want you to start resolving this one. Of course, I'm seeing you must do. Start resolving. I know you studied different ways of resolving. So this time, is yours to resolve that. Resolve it as I look at you, then when you finish, we move on. Okay? Begin. Yes, so you should have resolved like along the x, it is a cosine function. So resultant force along the x, I begin with this one, 3.375 cos of this angle, which is 75.5, then plus 2.7 cos now of this cos of that angle, which is 360 minus 75, which is 284. And when you resolve that one, you get 1.521. Then along the y, they are the same, but it is the sine function. So it's 3.375 sine 75.5 plus 2.7 sine 284.5 degrees, and that one should be able to give you 0.653 Newton. So we have got the vertical components and the horizontal components of these forces. Then when we reach there, what do? One is vertical. This is always like this. Then since it is positive, they are both positive. The y positive meaning it is upward, and then the x positive meaning it is in this direction. So we can have one of our final diagrams. This one is 3, the x1 is 1.521 Newton, then this one is 0.653 Newton. How do you get the resultant? We have seen that one before. You don't struggle. That is the F resultant, where this is this, then this one is here. So that the F resultant is the square root of 1.521 squared plus 0.653 squared. And when you press that one on the calculator, you get 1.655. 1.655 Newton. I know some of you had reached this level. Congratulations. I know somebody had reached this and this. Congratulations. And I know somebody did not resolve the same way I resolved it. Used some other ways. All that is understanding. But finally, when you do it in the right way, we get similar answers. So this is our resultant force. But force is a vector quantity. We need the direction. At which angle? That angle tan alpha is opposite, which is 0.653 out of adjacent, which is 1.521, and alpha, our alpha will become 23.2 degrees. Our alpha becomes 23.2 degrees. All these ones, we get them from the calculator. How do we conclude? The resultant force here on C is a force of 1.655 newtons at an angle of alpha, at an angle of 23.2 degrees. You can see this angle is here above the positive horizontal axis. That is the understanding that I would want us to move in, so that we all move in the same direction. That is the understanding that we can move in. So you have to tell us the force and then the direction. There you have given us the force as a vector quantity. But if you say the force is 10 Newton, it's like somebody who has said the mass is 1 kilogram, okay, or 0.1 kilogram. You have really not given us the direction of force, and therefore you neglect the issue that it is a vector quantity. It is now you. Can you do something? Can you do something? I am going to give you something simple so that you can do. I'm going to give you this kind of a thing, so that if we have, this is your activity, and then you do and send me. This is 1 microcoulomb, this is 2 microcoulombs, this is -3 microcoulombs, and this is 5 microcoulombs. This is a distance of 4 centimeters. This is a distance of 3 centimeters. So those charges are in air. That's what you need to know. So the charge of +1 microcoulomb, +2 microcoulomb, -3 microcoulomb, +5 microcoulomb are at the vertices of the rectangle as shown, which is situated in air. Calculate the resultant force on the charge of +2. Calculate the resultant force on the charge of +2 microcoulombs. I am confident and I am very sure that you are going to get it 100%. Begin slowly, do it, move slowly. You always feel the beauty of the science as you make it flow. When you force science, it be like it is complicated. But when you just have science like you are having breakfast, I told you, for us, understanding is our breakfast. At BAC Science Education Consultants, BAC. Without you forgetting to subscribe to our channel. That's me, Tr Cos.